This question came in 2016 for 1 mark in set 1 for EC gate. Let's read the question. A small percentage of impurity is added to an intrinsic semiconductor at 300 Kelvin. So, if you see, a small percentage of impurity is added to an intrinsic semiconductor. To a pure semiconductor, there are some impurities added. Which one of the following statements is true for the energy band diagram shown in the following figure? Now, if you look at this energy band diagram, what we notice is bottom edge of the conduction band EC, which is this, and top edge of the valence band EB is mentioned here. Okay. Now, we have a new energy level here. Now, when we add dopant atoms, we actually get this new energy levels. Okay. If it is an n-type semiconductor, we get energy level called ED, the donor energy level. And if it is a p-type semiconductor, we have seen in theory videos that we get a energy level called EA. These energy levels are the energy levels of the dopant atoms. Now, in case of n-type semiconductor, this energy level will be close to EC. And in this case, this EA will be close to EB. We have seen these concepts. If the energy levels are very close to conduction band for n-type, they are called shallow dopants. The dopants are called shallow dopants. And in case of p-type, if the introduced energy level, which is the acceptor energy level, is close to EV, that will be called again shallow dopants. Okay. If they go very close to the mid of the energy band gap, they are called deep dopants. Now, in this case, we can see that there is a new energy level introduced, which is very close to EC. If you look at the value here, this is 0.01 electron volts. Let's say, for example, in silicon, this energy band gap would have been 1.12 electron volts at room temperature, for example. So, to understand this energy level, which is very, very small compared to the energy band gap, which means this new energy level is very close to EC. This happens only in n-type semiconductor, which means the introduced dopants are basically donor dopants. So, let's now look at this options. So, intrinsic semiconductor doped with pentavalent atoms to form n-type semiconductor. Yes, that makes sense, because we are talking about n-type semiconductor due to which a donor energy level is introduced close to EC. Obviously, donor dopants, the pentavalent atoms introduced to form n-type semiconductor. So, we don't have to look at the other options. The answer is option A.